morning, students. So, trigonometry is basically not chapter 2, but it is chapter 5, first part. So, trigonometry is associated with the measurements of 3D three-sided polygons, or we can say three-sided shapes, or we can say trigonometry is somewhere a geometric construction which we can do. So trigonometry is associated with measurements of 3D three-sided polygons, as well as trigonometric functions occur in transformation, vectors, geometry, quaternions, and interpolation. So all these things are there with the trigonometry. As well as when we split the word trigonometry here, it is into its constituent parts. Tri means gone and metry. So we see that it is to do with the measurement of three-sided polygons, that is triangles. So three, that is tri is 3, gon is polygon, metry means for the calculation or measurements of three-sided polygons is done using trigonometry. It is used for the analysis and solution of problems in computer graphics. So basically trigonometry is being used for the solutions. As we know, trigonometry is used for measurements of angles as well, and the two units used for angle measurements in trigonometry are angles and radians. So the degree of unit of measure derived from defining one complete rotation as 360 degree. The radian is an angle which is created by circular arc, and its length is equal to the radius of circle. So arc's length is equal to the radius of the circle. Also, its angular measure does not depend on an arbitrary constant. So angular measure is the arbitrary constant which is being taken on the degree of angle which is being given. So they have given an example of a circle in trigonometry. Suppose if you want to take the area of a circle, you have a formula but for that the total area of a circle is 360 degree. On the basis of that we can do the calculations. So the perimeter of circle is 2 pi r, where 2 pi radians correspond to one complete rotation, and is 1 radian corresponds to 180 upon pi degree. So this is given in the form of trigonometry, that 1 radian of circle is equal to 180 upon pi degree, and which is approximately 57.3 degree. So pi upon 2 is 90 degree. Please keep this in mind. Pi is equal to 180 degree. 3 pi upon 2 is 270 degree, and 2 pi is equal to 360 degree. So these are the values. So it majorly goes on increasing by double values, that is pi value is 180. Pi, if I divide by 2, it's 90 degree. If 3 pi by 2, if I multiply 3 upon 2 by pi, it is 270 degree. Whereas 2 into 180, if I do, it's 360 degree. So pi value is being given. So for that, the next is the measurements of angles are given here. The measurements of angles is at the heart of trigonometry, and the two units which are there are degrees and radians. And the degree unit measure derives the defining complete rotation, that is 360, as I explained you. And each degree divides into 60 minutes, and each minute divides into 60 seconds. Likewise, the radian of an angular measure does not depend on any arbitrary constant. It is not given, it is depending on the angle which it provides. It is the angle created by the circular arc whose length is equal to the circle of radius. So these are the values which are calculated, and because of which the values which we get is this one. So these are the values which we are getting with the relationship of degrees and radians. So 360 is total, and then pi is 180. Pi, if I divide by 2, it's 90. If I multiply 3 upon 2 by pi, it's 270. So this is basically the value. So the mathematics for computer graphics is totally dependent on hypotenuse theorem, as we are dealing with the trigonometry, that is triangle, that this is the adjacent side, this is the opposite side, and this is the hypotenuse side. So hypotenuse is the combination of opposite and adjacent with their square roots. So that is trigonometric ratios for right angle triangle. And with this what we have is, for sine we have plus plus minus minus. Likewise, So we'll go with this. The trigonometric ratios. Triangle possessed some inbuilt properties. Now triangle has some inbuilt properties like the ratio of sides and their associated angles. That is, abbreviations which are taken for trigonometry are sine, cos, tan, cosec, sec and cot. So O is opposite, H is hypotenuse and H is adjacent. So here how do we write? That is, sine beta is equal to opposite upon hypotenuse. Cos beta is equal to adjacent upon hypotenuse. Tan beta is equal to opposite upon adjacent. Cos beta is 1 upon sine beta. So these here, these are actually the formulas which we'll keep in mind when you read. And if we take the opposite, that is cosec will be the opposite of sine beta, so they write 1 upon sine beta. Sec is the opposite of cos beta, so they write 1 upon cos beta. If they have cot beta, they will write the opposite of tan, that is 1 upon tan beta. Likewise the formulas are being taken. So the sine cos functions have limits plus minus 1, so they have limits of plus and minus 1, whereas tan has limits plus minus infinity, so they will not take 1, they will take infinity in tan. And for cos and sine they have plus minus 1. The signs of functions in 4 quadrants, you have 4 quadrants in your graph, so it is like plus plus, plus minus, minus plus and minus minus. So with this what you have is, you have 4 quadrants, and for that quadrants, for sine you have plus plus, minus minus, for cos you have minus plus, minus plus, and for tan you have minus plus, plus minus, so the opposite of cos. And whereas somewhere we can see sine is vertically correct, horizontally correct, cos is vertically correct, and tan is combination and it's crisscross multiplication, which we can see while remembering it in the quadrant format. So the example here which is taken for the trigonometric ratio is, example shows a triangle where hypotenuse and one angle are known, the other side are calculated. So what I have to calculate? The other side. And for calculating the other side, h upon 10, that is adjacent side upon opposite hypotenuse, is equal to sine 50 degrees. So angle which is given is 50. So what is the formula here? For if adjacent and what is given, adjacent is given and hypotenuse is given, what I have to calculate? The opposite side. So for that I can use sine, sine has opposite upon hypotenuse, so h upon b is equal to sine 50, we will use h is equal to 10 into 10, here it is getting divided, will multiply here, and sine 50, 10 into sine 50 degree is 0.76601. So whereas when multiplied by 10 it gives 7.66. Likewise cos, if I take cos b is equal to 10 into cos 50, which means 10 into 0.64279, b is equal to 6.4279, which is the answer which they have calculated. This is the normal calculation which we do. With this, next topic is inverse trigonometric ratios, where when we are inverting the values, inverse trigonometric ratios. There is an associated ration with every single value angle, and to convert one angle into another angle we need functions. The functions sine, cos, tan are used to convert angles into ratios. The inverse function sine minus 1, sine cos 1 and cos minus 1 and tan minus 1 convert ratios into angles. So sine 45 is 0.707, their sine minus 1 will be 0.707 is equal to 45. That is, the inverse ratio is being calculated. That is, by multiplying it by minus 1 we get the degree, by multiplying it by degree we get the decimal value. Although sine and cos functions are cyclic functions, so sine and cos functions are cyclic, and but inverse functions return angles over specific period, so they give angles in return, so they have specific calculation method. So trigonometric relationships. Cos beta is equal to sin beta plus 90. Sin beta upon cos is tan beta. Sin square plus cos square beta is equal to 1. 1 plus tan square beta is equal to sec square beta. 1 plus cot square beta is equal to cosec beta. So these are the trigonometric relationships which are being there for an arbitrary triangle, which are being defined. With this, we'll stop here for this lecture. We'll continue the next topic in the next lecture. Thank you.